This training mission follows the procedures described on the flight manual of the real aircraft, adapted for use on the A-4E Community Aircraft Module of DCS. The procedure step numbers, when provided, corresponds to those of the NATOPS manual. For brevity, we will skip those steps that corresponds to items not simulated yet, or that can't be performed on DCS. Even though the interior inspection is not really needed, as on DCS it is assumed already done, on this training mission you can choose to perform the interior inspection anyway, to provide cockpit familiarization to new pilots of the A-4E. If you are short on time, you can choose to skip all checks and tests that are non-essential on DCS. The cold start procedure includes the following sections. Interior inspection. Before starting the engine. Starting the engine. Post-start checklist. If the cockpit interior is too dark, activate the flashlight with right Control plus L. If the yellow cross cursor is not visible, press left Alt plus left Shift plus C to make it appear. You can adjust the sound volume produced by the background air traffic, by moving the in-cockpit sound slider, on the DCS options, audio screen, which you can access by pressing the Escape key. This instructor's volume level can be adjusted with the helmet sound slider. Also, you can press spacebar to skip long voiceovers. Press backspace if you want to perform the interior inspection section of the cold start procedure. If you prefer to skip this section, press spacebar. You have selected to perform the interior inspection. Interior inspection. 2. Emergency speed brake knob. Normal. The emergency speed brake control can be used to open or close the speed brakes in the event of an electrical failure. A left click will extend the speed brakes, a right click will retract them. 4. Oxygen switch. On. Check flow, then off. When the oxygen switch is turned on, oxygen is delivered from the supply system to the oxygen receptacle located on the oxygen and anti-G panel, on the left console. 5. AFCS standby switch. Off. The Automatic Flight Control System, AFCS, is an autopilot system, which can maintain heading, altitude and pitch and bank angles, and perform a coordinated turn to a pre-selected heading. 6. AFCS, Aileron Trim Switch. Norm. This switch is usually in the norm position, but if after disengaging the AFCS you find that the aileron trim is not operating correctly, then switch it to the EMER position. This should restore normal trim operation. Currently, the switch is animated, but its operation is not yet simulated. 7. Emergency fuel transfer switch. Off. In case of a failure of the fuel transfer pump, the wing fuel switch allows the transfer of fuel using wing tank pressurization. Moving the switch to the EMER trans position allows engine compressor bleed air to pressurize the wing tank. Fuel is then transferred to the fuselage tank through the pressure fueling line. 9. Drop tank switch, off. Set the switch to off, with a right click. 10. Radar selector switch, off. The APG-53 radar system provides search or mapping capabilities for navigational purposes, 2 modes of terrain clearance for obstacle avoidance, and air-to-ground slant range for weapons delivery. Automatic fire control is not provided. Operating controls are provided on the radar control panel at the right console, on a small radar switch panel near the bottom center of the instrument panel, and around the perimeter of the radar scope. 12. Fuel control switch. Primary. The engine fuel control is a hydromechanical device that has 2 modes of operation. Primary, where it senses inlet air temperature, burner pressure, high pressure compressor speed, and throttle position. When the throttle is moved, the fuel control varies the fuel flow optimally while keeping a safe tailpipe temperature. Manual, is a backup mode, where the fuel control compensates automatically only for variations in altitude and airspeed. 13. Manual fuel shutoff control lever. EMER off, then normal, cover down. The fuel system incorporates a manually operated fuel shutoff control lever located outboard of the left-hand console. Its EMER off position stops all fuel flow between the fuel system and the engine. A spring-loaded cover is provided to prevent inadvertent movement. 15. Jto arming switch. Off. J80 stands for Jet Assisted Takeoff System, which provides the aircraft with additional thrust during takeoff. On the A-4E, a J80 rocket bottle is mounted on each speed brake. Each bottle is capable of producing 4,500 pounds of thrust for a period of 5 seconds. This system is not currently implemented, but it is planned for version 2.1 of this community mod. The J80 arming switch arms the firing circuit. The J80 indicator light should come on when the arming switch is energized. The light can be pressed to check its bulb. 16. J80 Jettison Switch. Safe. When placed on the jettison position, hydraulic pressure is used to release the J80 mounting hooks, to release both bottles simultaneously. An interlock in the speed brake electrical circuit prevents their operation with J80 bottles attached. Be sure the speed brake switch on the throttle is in the closed position, otherwise, upon release of the bottles, the speed brakes will open. The J80 firing button is located at the end of the catapult hand grip, and is used to activate the bottles when pressed while on the takeoff run. Since the button is not clickable, bind it to your HOTAS or use the Q key. Once airborne, the J80 firing button is used to manually dispense chaff. 18. Speed brake switch. Closed. Confirm that the switch, located on the throttle grip, is on its forward position. Actuate it with the HOTAS or the B key. 19. Master exterior light switch. Off. The master exterior light switch, on the outboard side of the throttle grip, controls power to the wing, tail, and fuselage lights. The switch has a forward on position, a center off position, and an aft momentary on position. You can toggle between forward on and off with the L key. On the sim, the momentary function is not modeled. 20. Flaps handle. Up. Split flaps are installed on the trailing edges of the wings, to increase lift at low speed. Hydraulically actuated, the flaps are controlled by the flap handle. The flaps may be extended up to 50 degrees by left-clicking the flap handle to down, or it may be stopped at any intermediate position by placing the flap handle at stop with a right click. When up is selected, the flaps will retract. The position of the flaps is shown on the flaps position indicator, but is not working yet as there is no hydraulic power when the engine is not running. To prevent structural damage, the flaps retract automatically when the airspeed exceeds 230 knots indicated. The spoilers are used to reduce the landing distance, by decreasing wing lift. Once armed, they will extend automatically when these three conditions are met. The arm-off switch is positioned to arm. The left main landing gear is on the ground. The throttle position is below 70% RPM. 24. Radar warning. Off. This switch energizes the APR-25, homing and warning system, which alerts when enemy surface-to-air SA-2 missiles launch. 25. Accelerometer. Push to reset. An accelerometer with 3 needles, registers and records positive and negative G-loads. One needle indicates the current G-load being applied, while the other 2 record the maximum negative and positive values achieved. Depressing the knob resets all needles to the normal, 1G, position. 26. Airspeed Indicator Set. This is a combination airspeed indicator and Mach meter. The airspeed portion of the dial is fixed and calibrated from 80 to 650 knots. The Mach meter scale is a rotating disc, marked from 0.5 to 2.9. Only a portion of the disc can be seen, through a cutout in the airspeed dial. Airspeed and its corresponding Mach number, are indicated simultaneously by a single needle pointer. On the edge of the Mach scale, an index mark can be used to set a Mach reference. Adjust it by turning the mouse wheel, while keeping the gauge knob pressed with a left click and hold. On the edge of the airspeed scale, another index mark can be set through a range of 80 to 145 knots. Adjust it by turning the mouse wheel, when the cursor is over the knob. Let's try it. Adjust the airspeed index for a rotation speed of 120 knots. Good, now adjust the Mach index to an optimal climb speed of 0.75 Mach. Correct, now press the spacebar key, to continue the training. 27. Vertical Velocity Indicator. 0. A vertical velocity indicator reflects the rate of change in atmospheric pressure as the aircraft climbs or descends. This rate of change is represented in 100-foot graduations between 0 and 1,000 feet, of ascent or descent, and in 500-foot graduations between 1,000 to 6,000 feet. 29. Radar Altimeter Off. The APN-141 radar altimeter provides accurate altitude from 0 to 5,000 feet. Its knob enables power to the gauge, and is also used for setting the low limit index mark. Let's try it. Rotate the knob with the mouse wheel and set the index mark to 200 feet. Good. This way the aircraft's low altitude warning system, LAWS, will provide an aural tone during 2 seconds and illuminate the LAWS warning if the aircraft goes below the 200 feet altitude that you have just set. 30. Emergency Stores Jettison Select Switch, as desired. This switch provides selection of the external stores to be jettisoned when the emergency stores release handle is pulled. WNG selects the wing stations, AL selects all stations. 31. All armament switches should be off. A. Guns. On the ready position, electric power is provided to the twin internal 20mm guns, leaving them ready to fire. Set to safe. B. Bomb arm switch. Arms the bomb's fuses, nose and tail or just tail. Placing the switch in off leaves the bombs unarmed and they won't explode if released. C. Stations. Select which stations will be released on the next attack. D. Weapon function selector knob. Configures the sight according to the selected weapon type. Its positions are off. Select this position when firing the internal guns or the external gun pods. All other stores will be inactive. Turn the knob to the next position, with a right click, to learn about each. Rockets. Fires both guns and rockets, when pressing the stick's trigger. GM unarm. On this position, pressing the trigger fires only the guns, while pressing the stick's weapon release button will fire just the rockets. Spray tank. The A-4E could be fitted with an 85-gallons tank for spraying chemical weapons. Was never used in combat and it's not simulated on DCS. Labs, low-altitude bombing system. This system was superseded by the more capable CP-741 bombing computer, so this knob position is non-functional. Bombs and GM arm. Used for both bombs and guided missiles, like the AGM-45 Shrike and the AIM-9 Sidewinder. CMPTR allows bomb release using the CP-741 bombing computer. The ground crew will program on the avionics bay the exact bomb characteristics of our current loadout. Now, return the knob to the off position by left-clicking on it 6 times. E. Master arm switch. Off. All armament circuits are controlled by this switch, with the exception of gun charging and emergency jettisoning of external stores. The master armament switch must be in the on position to energize armament circuits. 42. Interior lights control panel. As desired. A. Adjust console lighting, by rotating this knob. A toggle switch with 3 positions, bright, dim, and medium, controls the intensity of the red console floodlights. B. Set instruments lighting by rotating this knob. C. Set white floodlights by rotating this knob clockwise. 45. DAC and antenna switch. As desired. The purpose of the switch is to enable the pilot to utilize the forward or aft antenna. The auto position enables automatic selection of the antenna that has best reception. On DCS it's currently animated, but non-functional. 46. AR-63 power switch. MCL power to off. The AR-63 Instrument Landing System, ILS, is the airborne portion of an all-weather aircraft approach guidance system. Coded signals from ground or carrier-based transmitters are received and decoded by the AR-63 for display on the ADI, in the form of vertical and horizontal director pointers. Its controls are located on the right console. MCL stands for Manual Carrier Landing System. 48. Rain removal switch. Off. The rain removal system utilizes high-pressure engine bleed air to remove rain from the glass center panel of the windshield. Not simulated, but the switch is animated. 50. Cabin temperature knob. As desired. The control is functional whenever the cockpit pressurization switch is in the normal position. The warmer arc provides automatic temperature control, so turn the knob to that position. 51. Cabin Pressurization Switch. Normal. When Norm is selected, and the canopy is closed, the cockpit is sealed and pressurized by engine compressor bleed air. Pressurization is automatically maintained at a predetermined schedule. The ram position opens a valve in the ram air duct, allowing outside air to ventilate cockpit. Set the switch to norm. 52. Windshield defrost switch. Hold. The switch controls a proportioning valve which serves to proportion air between the windshield defrost manifold and the foot warmers. When the defrost switch is placed in increase, the valve increases the airflow to the windshield. When placed in its decrease position, the valve increases the airflow to the foot warmers. The hold position allows the proportioning valve to remain as is. 53. Exterior lights control panel. As desired. The exterior lights control panel, on the right console, contains switches for control of the exterior lights. A. Probe light, off. The air refueling probe light is located on the right-hand intake outboard lip. B. Taxi light, off. The taxi light is installed on the right-hand main landing gear door. C. Anti-collision beacons, set to on, as we will be starting the aircraft soon. The aircraft has two flashing red anti-collision beacons, one mounted on the top of the fuselage and the other mounted on the left main gear strut fairing. D. Fuselage lights, set to bright. These are semi-flush, white, fuselage wing lights, located under the leading edge of each wing. E. Navigation lights, wing and tail, set to bright. F. Navigation lights mode, set to steady. The A-4E also has angle of attack approach lights, mounted in the leading edge of the left wing. The approach light circuit is controlled by the tail hook switch. DCS Mission Preparation. Before starting the engine, you can make requests to the simulated ground crew to prepare the aircraft for the mission, with a proper countermeasures release program, and an effective weapons loadout. Request countermeasures. The A-4E can carry up to 60 countermeasure packets, which you can dispense when in combat, to defend against enemy missiles. The packets can be either chaff, for use against enemy radar-guided missiles, or flares, for use against infrared-guided missiles. The normal countermeasure mix is 30 chaff plus 30 flares, though you can opt for carrying instead either 60 flares or 60 chaff. On DCS, you can ask the ground crew to adjust the countermeasures dispenser programmer, in order to release a custom sequence of countermeasures. This is done through the DCS kneeboard. Open it now by pressing right Shift plus K. Page the kneeboard forward, by clicking the greater than icon, or by pressing the close square bracket key, until the countermeasures page is displayed. Press spacebar, once the page is displayed. Use the following keys to modify the countermeasures release program. Right Shift plus Right Alt plus 4. Burst is the number of chaff or flares to be dispensed on each release cycle. For example, set it to 2. Right Shift plus Right Alt plus 5. Burst interval is the time lapse between each CM released in a burst release. Adjust it to 0.3 seconds between each individual flare or chaff. Right Shift plus Right Alt plus 6. Salvos is the number of bursts to be released by the program. Set it to 12 salvos. Right Shift plus Right Alt plus 7. Salvo interval is the time lapse between each individual burst. Adjust it to 4 seconds between each salvo. Good, the ground crew has programmed the ALE-29 countermeasures dispenser to release this sequence of chaff or flares when you need to. Close the kneeboard by pressing right Shift plus K again. Request weapons loadout. The weapons that you can load on the aircraft are selected on the Mission Resources window. You can display this window by pressing the left Alt plus apostrophe keys, or you can also bring it up using the DCS Communications menu, by pressing the backslash key, and then select F8. Ground Crew. F1. Rearm and Refuel. You can try it now and inspect your current weapons loadout. Once you have reviewed it, close it by clicking the Cancel button of the window, since we don't really want to change any item for this mission. press backspace if you want to perform the check steps of the cold start procedure. If you prefer to skip those tests, press spacebar. You have chosen to perform all the functional checks of the cold start. Starting the engine. The A-4E electrical system does not include batteries. Also, there is no APU to provide starting air. Because of this, an external electrical power supply and a source of starter air are required for ground starting the engine. 1. External ground power. Connect. Bring up the communications menu, with the / key. Select F8. Ground crew. F2. Ground electric power. F1.
Chief, turn on the ground
Turn
power.
power on. Even though we ask just for ground electric power,
Copy.
the ground crew is also connected starting air to provide airflow to rotate the turbine during the
Ground
ignition.
power is now on.
2. Master press to test. Check. Press and hold the master test button to check all the warning lights. APC. ECM. Angle of attack indexer. Wheels. Labs. Laws. IFF. Fire. OBST. Pilot and armament advisories. Radar altimeter on. Oil low light. The fuel quantity and liquid oxygen quantity indicators will rotate counterclockwise. The liquid oxygen warning light will come on when its needle passes through 1 liter. 3. Throttle off. Check that both the virtual aircraft throttle and your real HOTAS throttle are at the off position. 4. Engine starter switch. Depress to start. When the switch is depressed, the starter air supply valve opens, allowing compressed air to rotate the starter. A holding relay retains the switch in the start position. Once the engine speed reaches approximately 50% RPM, the engine starter switch will pop up, stopping the air supply to the starter. 5. At 5% RPM throttle to ignition, by right-clicking the throttle lever. The ignition switch is actuated by movement of the throttle inboard, from the off position, into the ignition position. 6. At 15% RPM. Throttle to idle, right-click again. This opens a fuel cutoff valve in the fuel control unit, providing fuel flow to the engine and allowing it to start. 7. Stabilized idle RPM. 56 to 58% at 20 degrees Celsius. Light off should occur within 20 seconds after the throttle is moved outboard to start the ignition cycle, and is indicated by a rise in EGT after the throttle is moved to the idle position. Normally, the engine will stabilize at idle RPM within 45 seconds from depressing the engine start button. 9. External electrical power and starting air. Disconnect. Now that our aircraft's engine is running, electrical power is being supplied by a 10 kVA, engine-driven generator, so we can now disconnect the external ground power. Bring up the communications menu, with the / key. Select F8. Ground crew. F2.
Chief, turn off the
Ground
ground
electric
power.
power. F2. Turn power off.
Copy.
This will have the ground crew disconnect from the aircraft both the electric and air supply connections.
Ground power is now off.
If light off is satisfactory and engine speed is stabilized with the throttle at idle, check the following. 1. RPM. Idle at 56 to 58% at 20 degrees Celsius. 2. Exhaust gas temperature. Between 200 to 340 degrees Celsius. 3. Fuel boost, light out, on advisories panel. 4. Oil pressure, 35 to 50 psi. 5. Oil quantity indicator, light out. Electronic equipment warm-up. The A-4E electronic equipment needs a warm-up time, before we are able to do their pre-flight checks. We will turn them to standby, so they can warm up while we do other checks. A. Turn the navigation computer to standby, for a 2 minutes warm-up. B. Turn the Doppler navigation radar to standby, for a 5-minute warm-up. C. ARS-63, ICLS system. It does not require warm-up, as it is solid state, but we can perform its bit test as follows. C1. Set the 3-position MCL power switch to on, with a left click. 2 red warning flags should appear on the ADI at the 12 and 3 o'clock positions. The vertical director pointer indicates full right and the horizontal director pointer indicates full up. both being almost out of sight. C2. To check the system, hold the switch in the bit position, with a left click and hold. C3. Correct functioning of the system is indicated if on the ADI the vertical pointer oscillates between 1/3 scale right and 1/3 scale left at a 4 second per cycle rate, and if the horizontal pointer is centered. When released from the bit position, the switch will return to the on position, and the test is terminated. Post-start checklist. When electrical power becomes available after starting engine, check the following items. 2. UHF function switch. Set to DR+G. The Skyhawk is equipped with only a single communications radio, an ARC-51A, UHF radio, which provides voice communication between aircraft, ships, or ground-based radio stations. This radio is energized by rotating its function selector switch from off to DR or TR+G. It can tune frequencies between 225 and 339.95 MHz. 4. TACAN switch, set to receive for a 3 minutes warm-up, then set to transmit receive. 5. AFCS set to standby. The automatic flight control system is the Skyhawk's autopilot system. It will maintain heading, altitude and pitch and bank angles, and is also able to perform a coordinated turn to a pre-selected heading automatically. Placing this switch to standby provides electrical power to the AFCS for warm-up. The system should be in standby at least 90 seconds prior to engaging the stability augmentation switch, or the AFCS main engage switch. 9. Fuel quantity. Check internal and external readings. The fuel quantity gauge indicates the total fuel available, in thousands of pounds. The range of indication is from 0 to 6,400 pounds. The highlighted toggle switch is used for checking external fuel load. The external fuel amount will be indicated when the switch is held to the EXD position, with a left click and hold. Check oxygen quantity. Take note. Oxygen is supplied by a vacuum bottle liquid oxygen converter mounted in the aft fuselage section. The bottle contains 10 liters of liquid oxygen when full. It should be noted that although 100% oxygen is used at all times, duration is greater at high altitudes. 10 liters lasts 60 hours at 40,000 feet, down to 7 hours at sea level. 12. Standby ADI, erect, off flag not visible. Adjust by left click and hold, and then turn the mouse wheel. 13. Compass controller panel. Set. Not simulated yet, but the panel elements are animated. On the real aircraft, you have to choose between free or slaved operation, the latter being preferable as it uses a flux valve to keep the gyro oriented to the magnetic north. 14. Rain removal system. Check for flow, then off. System not simulated, but the switch is animated. 15. AFCS run checks, then ensure off after checks completed. The AFCS checks are performed using the AFCS test panel, on the right console. The three indicators R, Y, and P, represent the control current to the AFCS servos for roll, yaw, and pitch respectively. The 1 and 2 switch allows two test conditions. The switch is spring-loaded in the normal position and when performing tests must be held in either test position 1, with a left click and hold, or test position 2, with a right click and hold. The AFCS mandatory check consists of 4 tests, performed with the AFCS engage switch enabled and while holding the 1 and 2 switch at test 2. Begin by lifting the 1 and 2 cover, by clicking on it. To begin the check, hold the 1 and 2 switch at test 2, with a right click and hold. Keep the switch pressed. Now, engage the AFCS. As we have the mouse busy, use the A key instead. 1. Aileron limit switch check. Move the flight stick to the right. At about half deflection, the autopilot should disengage, and the engage switch will be seen to slip to its off position. Good. Now center the stick and re-engage the AFCS by pressing A. Now move the flight stick left. At about half deflection, the autopilot should disengage and the engage switch will go off. Correct. Now center the stick and re-engage the AFCS by pressing A. Good. Remember to keep the 1 and 2 switch holding at test 2. Now, move the trim hat to the right, with your HOTAS or the right control plus / keys. The autopilot should disengage, and the engage switch will flip to its off position. Good. Now center the trim hat by press and hold on to the left control plus D keys, and re-engage the AFCS by pressing A. Now move the trim hat to the left, with your HOTAS or the right control plus / keys. The result should be the same as before. Next, center the trim hat by press and hold on to the left control plus D keys, and re-engage the AFCS by pressing A. 3. Trim monitor switch check. On this check, move the flight stick aft, and then move the trim hat toward nose up, with your HOTAS or the right control plus dot keys. The autopilot should disengage and the engage switch goes to off. Good. Now center the trim hat by press and hold on to the left control plus D keys, and re-engage the AFCS by pressing A. Now, move the flight stick forward and then move the trim hat toward nose down, with your HOTAS or the right control plus semicolon. The results should be the same as before. Good. Now center the trim hat by press and hold on to the left control plus D keys, and re-engage the AFCS by pressing A. (4) Autopilot check. Depress the flight stick's AP override button, using the HOTAS or the left control plus A keys. The autopilot should disengage, and the engage switch will flip to its off position. 5. The pilot will know from the above tests that the AFCS has electrical power on all its servos and that the safety circuits are operating. Release the 1 and 2 switch. Now, close its cover, and turn the AFCS standby switch to off. Leave the switch at off for takeoff. Good. This finishes the AFCS mandatory check. Press spacebar to continue. Navigation computer check. The ASN41 is one of the earliest Doppler navigation computers, used in conjunction with the APN-153 Doppler navigation radar. It is a primitive unit that can handle only 2 waypoints, D1 and D2, plus the present aircraft position. 1. Turn the function selector knob to test. The computer will do a pre-solved navigation solution, and show it on the navigation displays and on the BDHI indicator. 2. Turn the BDHI switch to the nav computer position, with a right click, so that its pointers show data from the navigation computer instead of the TACAN. The test values should be: wind speed indicates 223 knots. Wind direction indicates 091 degrees. Latitude present position shows south integration. Longitude present position shows east integration. BDHI pointer 2, the one with double needle, indicates 30 degrees right. BDHI pointer 1, single needle, its indication depends on present position and destination. 3. Turn function selector switch knob to standby. 4. Turn function selector switch knob to D2. Using the slew knobs, input latitude and longitude for the D2 waypoint. For this training mission, let's set as D2 the coordinates of Rota International Airport. Its latitude is 14 degrees, 10 minutes north. Set the counter by left or right click on the outer ring of the knob, and hold the mouse button until the desired value is displayed on the visor. Good. In the same way, now enter its longitude. 145 degrees, 14 minutes east. Now, turn function selector switch knob to D1. Same as before, enter latitude and longitude destination counters for the D1 waypoint. For this example, let's set D1 to Andersen Air Force Base. First, enter its latitude, 13 degrees, 35 minutes north. Good. In the same way, now enter its longitude, 144 degrees, 56 minutes east. On the real A4 you would now input, on the present position counters, the latitude and longitude of your current location. However, on DCS, these coordinates have already been entered, saving you this step. 7. The magnetic variation is the angular difference between the magnetic north and the true geographical north, and it varies according to the date and what is our current location on the surface of the Earth. On the DCS maps, the magnetic variation average values are: Caucasus, 6 degrees east; Nevada, 12 degrees east; Normandy, 8 degrees east; Persian Gulf, 1.6 degrees east; the Channel, 10 degrees east; Syria, 5.1 degrees east. For our current map of Marianas, the average magnetic variation is 0.9 degrees east. Input the value by left-clicking and hold over the highlighted knob, while at the same time turning the mouse wheel. You may need to use both hands. 8. Input wind direction and velocity. Since once in flight, the Doppler radar will feed calculated wind data to the navigation computer, this step is not needed. 9. Leave function selector knob in standby. Navigation radar check. 1. Turn selector switch knob to the test position. The memory light should illuminate. The ground speed dial should read 121 knots, while the drift angle dial should read 0 degrees. 2. Turn selector knob to standby. Prior to takeoff. Turn 16. All flight controls. Free, full travel proper movement. Move the control stick left to right and front to back, checking that the control surfaces move accordingly. Move the rudder pedals left and right and confirm that the rudder moves accordingly. 17. Check flight devices operation. A. Flaps, full open. Check the extension looking at the gauge. Use the HOTAS or the F key. B. Speed brakes, open. Use the HOTAS or the B key. C. Hook. Down. Extend by clicking the cockpit lever. You can also use your HOTAS or the left Alt plus G keys. D. Spoilers, up, then cycle with throttle. The spoilers are wing-top deployable surfaces used to reduce landing distance. They retract automatically when RPM is over 70%, to cater for a bolter trap. To perform this check, extend the spoilers with the engine at idle, then hold the wheel brakes and increase RPM to 70%. To check the automatic retraction, use the HOTAS or the S key. Retract flight devices. A. Flaps, set at half extension. Check the extension looking at the gauge. B. Speed brakes, closed. Use the HOTAS or the B key. C. Hook. Up. Click on the cockpit lever again, or use either your HOTAS or the left Alt plus G keys. D. Spoilers, down. Use the HOTAS or the S key. 19. Rudder trim, check and set at 0. Turn the knob while checking the left gauge. (21) Horizontal stabilizer. Set. Adjust using the trim hat on the HOTAS. For short takeoff, use 6 degrees nose up. Aileron. Stick centered, check both left and right trim. Adjust using the trim hat on the HOTAS. 23. Drop tank pressure. On. Fuel transfer from the drop tanks to the integral wing tank and fuselage tank is effected by means of drop tank pressurization. Placing the switch on press directs engine compressor bleed air to the drop tanks. 24. Drop tank pressure, off. Placing the drop tank transfer switch in off de-energizes the drop tank air. 25. Emergency transfer. Check. Emergency transfer of fuel from the wing tanks to the fuselage tank is possible. A wing fuel switch provides for the transfer of fuel by wing tank pressurization. Moving the switch to the EMER transposition closes the wing tank pressure and vent valves, allowing engine compressor bleed air to pressurize the wing tank. Fuel is then transferred to the fuselage tank through the pressure fueling line. Congratulations, this concludes the after-engine light-off section of the Shore Cold Start procedure. The aircraft is now ready to taxi. You have successfully finished this training mission. On the next mission we will learn the shore taxi and takeoff procedures. For now, please exit the training by pressing spacebar.